Hi there, in this video clip I want to talk about the Earth's resources and the wet stuff, water. Everything comes from land, sea and the air. So you start thinking about houses, buildings, food, warmth, I can't spell it, shelter, essentials. Water is an essential commodity for life. These natural things, from the land, the sea and the air, they will not last forever, and therefore there's the concept of sustainable development. It means this: using the resources sensibly, not for just today but for tomorrow and future generations. Chemistry is helping a little bit. Chemists invent different things, and these different things maybe make different materials, biofuels, different types of polymers and plastics, energy, nuclear fission, nuclear fusion. So man and the scientist in their particular, they should be planning ahead for future generations. For example, chemists, they are making different materials, different drugs, different fertilizers. So in fact, what we're trying to say is, reducing the use of the natural materials by creating new ones. Water is a very important natural material, and let's look at potable water. Is water that's fit to drink. Where's it from? What do we do with it? Well, succinctly, water, would you believe this, comes from the sky in the form of rain, and it's collected in reservoirs, huge man-made, if you like, artificial lakes or ponds. And then what happens is it's then filtered to remove any particular matter, any solids, particulate matter. It's filtered at a treatment centre, and then it still contains things like bacteria, microbes, maybe some unwanted salts, ions, and it is then treated with things like chlorine gas, that kills off microbes, ozone, O3, that's a new gas, it's like oxygen but slightly different, and they put in fluorides. What they kill off the microbes, and these days they put in fluorides, that's to help your teeth, healthy teeth, and bones, bone strength. And that is potable water, is water that is drinkable. However, it still would contain some naturally occurring ions from, you get water in the south of England, it's often chalky, and it contains calcium ions, Ca2+ ions, and magnesium ions, Al. magnesium Mg2+ ions and aluminium ions Al3+. But when you start thinking about the amount of water we all use, you just think, dish washers, washing machines, showers, cooking, washing, showering, cleaning your teeth, all of that water it becomes dirty and waste water, and that could come from domestic use, industrial use, agricultural use, manufacturing use, and it has to be reused. So when you flush your toilet, all that stuff goes to a sewerage plant, and in the sewerage plant it's cleaned up. When we say it's cleaned up, it means it's filtered a couple of times. That removes all of the solid matter, the big particulate matter, and I don't want to discuss that in any greater detail. And then it's put into sediment tanks, sedimentation, it's left there, and gradually all the heavier solid particles float to the bottom, or maybe they add coagulants, so all this particular matter sticks together, it forms larger particles, lumps, sludge, and then the water then is pumped off, and then maybe then this sludge, which could contain bio things, bacteria, organic matter, it then may be fermented or subject to anaerobic and aerobic, that is with and without oxygen, and eventually that will break down into harmless things, maybe carbon dioxide and water. So this water is then, what happens to it? It's like the industrial cycle, it goes back into the system again and it's reused. So the water we have in our taps, it's probably used time and time again. It's it's used, it's cleaned, filtered, etc. Then it's pumped back into the system. If we haven't got enough natural water, there's two processes which we can obtain water from the sea. Seawater is salty water. It contains sodium chloride and other salts, magnesium salts, calcium salts, etc. And we can remove them by using two processes. The one is distillation, and we've seen this in the past. You get salt water, heat it up, the water comes off in the form of steam, and the steam is then condensed, and then you get pure water. And if you go abroad, you see these huge big tanks. The water is heated, then the steam comes off and that's condensed, and these are called desalination plants. Saline is salty water, desalination taking out the salt from the water. And there's another technique, it's called reverse osmosis. I'll just draw a very simple diagram of what happens. Here is a huge vat, big tubes, and here you've got what's called a semi-permeable membrane. It allows small guys through and bigger guys, those molecules are too big to pass through. It's like a micro sieve. So that is filled with salt water, and there's a piston and it's under pressure. Let me just draw it as a solid thing. What happens is the salt water is forced under pressure, and the larger particles, they remain there, and pure water comes out there. The problem is with distillation of water, it's expensive. Reverse osmosis is expensive, but they are used. You go to the Greek islands or places like that, and they're both used. Well, that's about it. But the thing is, man should be thinking about, like I've already said when I started to talk about this clip, not today, not tomorrow, but in the future, managing the Earth's resources. By the way, at the end of this talk, I just had a quite frightening fact. Millions of people still die due to impurities in water. The bacteria carries these diseases, and there's millions of people still die due to lack of sanitation. I'll be talking more about these microbes and bacteria in a future video clip.